Hi, we're video group 8 and we're doing problem 7.2 number 2. So this is the problem here. You have your transfer function being 33 over 200 times s plus 100 over s plus 33, with the input being f of t equals 8 sine 50t. So the input is in the form f of t equals a sine omega t. So a is 8 and omega is 50. So essentially what the transfer function allows us to do is go from this input function to a steady state response over here. And these are the respective forms. So the first thing we have to do this is find the magnitude. And magnitude is equal to b over a, with b being the amplitude of your steady state response, and a being the amplitude of your input function over here. So basically the first thing you have to do is replace s with j omega in your transfer function, with omega being 50. So down here, this was subbed in, and so you can see that. And you just take the magnitude of each complex number and then combine them to get that for your m value. Then because m is equal to b over a, then you're able to solve for b, since we know both m and a. We're able to get b right here.
Okay, so the next thing we have to do is we have to find the phase shift so we can substitute it into the steady state form here. So that's going to be the angle of the transfer function in the frequency domain. And you have three components of the angle. And so like we did in class, we're going to take the angle of the 33 over 200, and then we're going to add the angle of the numerator of the transfer function and subtract the angle of the denominator of the transfer function. And because these are complex numbers, you have the form a plus bj, so you know that the angle is going to be equal to the inverse tangent of b over a. So here's the calculation for the angle, and you know that the angle of 33 over 200 is 0 because that lies only on the real part of the s-plane. And so then you're just going to add the tangent inverse of b over a for this component and subtract the inverse tangent of b over a for this component. And you end up getting that the phase shift is negative 0.5238 radians. And so then you just have to substitute the values for b and for the phase shift into the final steady state form, which is b sine omega t plus phi. So you get that the steady state form is equal to 2.4634 sine of 50t minus 0.5238.